Good morning, everyone. Welcome to part one of the TVT AI webinar series. And today we're talking about an intro to AI and its evolution in Business Central. My name is Robbie Goff. I'm a solutions alchemist at TVT. I work with AI lots. I work with it with customers. I work with it for internal productivity. I've got my own personal projects. I have an interest in it generally, I suppose. And I'm joined by Paul and Nikki. Do you guys want to introduce yourselves?
I'll go. Means I'm next on the slide. Yeah, I'm Paul Cartwright. I'm the CTO at T Vision Technology. Yeah, like Robbie, I do a lot of work with AI, implementing for customers, primarily around Business Central, which makes sense given our industry. But yeah, much like Robbie, I use it a lot for my own on the back end of doing work, and also some very ranging from very interesting to very geeky hobbies around it that I won't share with you.
I'm Nikki. I'm the sales executive assistant. I usually work in funding, licenses, and anything to do with partners. But yeah, I'll be keeping an eye on the chat. If there's any questions, please pop them in there.
Nice. So before we move on to the meat of the session, we'll do a quick introduction. Housekeeping wise, if you could put your questions into the Q&A section of the chat. If they fit the flow, then we will answer them as we go. But if we have to answer some questions at the end, we should have 5 or 10 minutes left at the end to answer those. Any we don't get to, I'm sure we can answer after the fact, then we'll email them all out later. I also believe the session is being recorded, and so if you need to drop off, or if you've got colleagues who wanted to make it but couldn't, we'll send the recording out, the deck out, and all of those Q&As as well. Briefly, why we're doing this today, why AI today? It's pretty simple, really. We've seen this generative AI explosion, a huge increase in adoption, things changing at a rapid pace still, AI being implemented and added to all sorts of software, including ERP. So now feels like as good a time as any to catch up on what's led us here, learn about the tools we've got now, prepare for what's to come, etc. And that's sort of driving this series of webinars. In terms of the agenda, we're going to start with setting the scene and talking about the types of intelligence, AI or otherwise, in software and ERP. We'll start with rules and automation and then build up towards generative AI. We'll then look at the timeline of generative AI. The session is going to be sort of focused around generative AI more than just general AI. We'll then look at the risks and realities, which there are none whatsoever. So a nice short section. And then we will look at where it's all headed and what you can do to prepare for it all. A very quick reminder, I mentioned at the beginning, this is the first in a series. So these are all of the AI webinars we've got planned. So if any of those jump out at you, hopefully all of them, then please make a note of the dates. It would be, we built this like a course. So it would be nice to see everyone here, also here on the 20th of January when we talk about extending BC MCP. Without further ado, though, let's get stuck in. And we're starting with the progression. Again, the focus of the session is generative AI, but BC, nav, software generally has had intelligence for some time. And we've split this into a few different categories, and we're going to discuss those categories. And the first place to start is with a form of intelligence, I suppose, called rules-based automation. And if not explicitly, implicitly, we all know what this is. This is just, if something happens, then do something else. And I suppose it's driven by an attitude, actually in AI, from the 50s to the 80s, that essentially posited that if we defined enough rules, that intelligence would follow. So you can see there, with enough rules, we can simulate that intelligence.
I think it's worth saying that this is just fundamentally how computers, up until the last few years, have worked. Everything is just this. The argument is that you can make every computer program in the world by defining a series of, if this happens, then do that, and if that happens, then do this, otherwise do that. But it's very procedural is the point. It's very knowable, very readable. Well, say very readable. In small scale, it's readable, but it's what we think of as a computer. I think it's a state machine. It's very, very logical, and can be understood by a mere mortal's brain, is the idea. I mean, us humans can read this and understand it and see what it's doing. It doesn't require any magic. Although that's the point, right? Is that it was at the beginning this was perceived as magic, and then we got to understand it. But
yeah,
it looks
exactly
like intelligence.
That. Exactly. And what are some examples of rules-based automation, Paul?
I think so. The one I always come back to is procurement and replenishment of stock. Like if you look at even in BC today, if you look at, you want to run the planning worksheets, the requisition worksheet, and it tells you you could argue intelligently how much stock to purchase. It is just rules. It's saying, well, if the amount in inventory minus the quantity on sales order is less than the reorder point, then tell me to buy the reorder quantity. And obviously you can go, that's a very simplistic idea, but it is that, right? These things which are, you could argue that's the machine intelligently making a decision about how much stock you need. It's just rules. It is you, and even if you go down to even the more complex versions of that, they are just more rules, more things you're checking, more if statements resulting in more then statements. So yeah, I always think that's a really good, like people think of that as quite complex. Like it's almost rocket science to get those things working ideally, but it is finite state. It is rules. You are defining rules like an admin box.
Yes. So, and crucially, it sometimes does feel like intelligence or artificial intelligence, but it's not. I put not really. It just flat out isn't. And
yeah. It's the reason. It's probably also the reason where people say, "Oh, the computer just did that." Oh, I don't. It did it randomly, and this is where we get into the no, it didn't do it. Like computers at this point don't do things randomly. You can reverse engineer and work out exactly the if statement that things happened in. There is no randomness to this.
Yeah, and it's not to say that there isn't a place for rules-based automation. There is, and always will be. But in terms of where it does fall down, it's stuff like being brittle. So we can define as many rules as we want, but once we hit an exception, you will at some point, then it's either going to fall down or it's going to pick up the wrong rule and do the wrong thing. And the way around that would be to continuously update those rules. But of course, that implies a huge maintenance overhead, and there's no sense of adaptability or reasoning. And it also requires structured and well-formed data. So, I jumped forward a bit there. Apologies. That was the scrolly wheel on my mouse. So, rules-based automation, it answers that question of how do we remove humans from predictable decisions, and we can do it with rules-based automation. We don't need AI for that necessarily. But what about the stuff that is not explicitly anticipated? And that's where machine learning comes in. So machine learning, clue is in the name. It's where the system learns from data instead of rules. So instead of a human writing down rules for every single situation, we feed a system or a model thousands, millions, billions of examples, and it begins to find the patterns itself. You can see there, it's not told what to look for. We don't tell it which rules to follow. It just works it out.
And this is still, at the end of the day, maths. Like the models we're talking, when we say a model, what we mean is a mathematical algorithm. It's just at the point we get to machine learning is these are become increasingly complex, but they're still written as they are mathematical logical procedures. But yeah, the idea is now it's the machine feeding back into that. It's a model that takes some sets of data and identifies patterns and uses that to update its own rules. So instead of the humans or us writing the if statements, that logical procedural stuff, the machine is looking at the patterns and itself generating those sets of argued procedural rules, but then adapting them over time, right? As you feed more data into after next month's sales are fed into the prediction algorithm, now it can update its rules to adapt the answers. So it's that idea of the machine feeding back into itself. As it says, as Robbie says, learning. The machine is learning in theory.
And we got this actually in NAV 2017, so almost a decade ago. And it landed in the form of sales and inventory forecasting, which is clearly quite a while before Copilot, which came in sort of 2023 around then. So the idea was that it would look at your historical sales data and come to its own conclusions about when you needed to order stock, etc., that kind of thing.
It's probably fair to say we tried to implement this a few times. It was fairly simplistic. The version we got in NAV 2017, it was really when we looked at it, and other people's mileage may vary. It was looking at a number and a date series. So it's saying, well, if that number goes up by 2 every month, it will continue to go up by 2 every other month. And it was a little bit more complex than that, but it was a pretty basic version of this machine learning in comparison to, you know, third-party tools that we were using like AGR and those sorts of tools that are really, you know, deep into this. The stuff we got in 2017 in NAV was a good start, but it was pretty simplistic. I don't think I saw many people really running too quickly with it. It was pretty basic.
Interesting. Okay. And we did then also get another model. We got the late payment prediction machine learning model, and that was in BC in 2018. But there was still a sort of ceiling to machine learning, or we wanted more. So we could analyze and we could predict, but there was still this sense that it couldn't generate new content. It couldn't draft emails or action on the insights it had found. It also dealt with data as opposed to natural language.
And it's worth saying that machine learning is still here. Like if you look at weather forecasting, that is machine learning on a massive scale. It's feeding massive amounts of data and still using it. So it's not this, I think it's probably worth saying, we're not talking about this progression as being, you know, we went from if statements to machine learning and then there was no more if statements. You know, machine learning came along and adapted that and it has continued to progress. Some would argue at the same pace as generative AI that we'll go on to in a minute, but it's still knocking around and it's still doing a lot of things. If you've ever done any sort of facial recognition, you know, or use those tools, that's all just machine learning in increasingly complex ways.
And that takes us on to the final form of intelligence that we're talking about in this section, which is generative AI, the paradigm shift. So generative AI, again, clue is in the name, creates rather than just predicting. And like Paul has said, it's still machine learning, but it's a subset. And again, instead of having that data as the interface, we have a natural language interface. And then we have these large language models that we'll talk about a bit later that do all of the reasoning. And here is a little bit to sort of describe exactly how generative AI works. So we have this reasoning piece. So we pass our messages in and it holds that context as it reasons and it chains it all together. It then has the generation piece. So we've given marketing text there as an example, because that is something you'll find in Business Central. We'll talk about later. We can generate emails as well. We can generate documentation. We can generate code and acting as well. And that's a bit of a precursor to agentic AI and the evolution of agentic AI, which we'll talk about a little bit later too. But so that's the progression. It's like Paul said, it's not like generative AI is a replacement for machine learning or for rules-based automation. We have our rules-based automation for reacting and for rules. We have machine learning for prediction. And then we have generative AI, which is this advanced version of machine learning, which is reasoning and it's generating.
Yeah, I think the reasoning is the big bit here. I think it's we'll talk in a second about kind of how the history is how it got to a point, but it's that idea that I mean, the first thing we ever did, I remember getting the first version, we asked it to write a poem, and then we asked it to adapt it to make it a Christmas poem about someone, and the magic of it was that it could adapt and it could take the input and apply what seemed to be somewhat human reasoning to how to solve the problem. If I said to you, go and write a Christmas poem about Robbie, what would you put? You can't predict. There's no history of data that can really predict it. It's the fact it seemingly goes away and applies a level of thought to its answers, and that's really the big key magic here. Is it seems to think, and I think that's what everything else is built on. If it just produced, if it was just a take some text and summarize it, that's all it could do, we probably wouldn't be where we are. It's the fact that it seemingly thinks or reasons its answers in some level of intelligence.
And we'll explore that a bit more now. That takes us on to section 3, which is the timeline from generation to action. And again, this section is going to be really the timeline of generative AI with a focus on that sort of 2017 through to now explosion in generative AI that led to agentic AI as well. So we'll start with pre-2017. I feel awful for all of the scientists and researchers who worked on Gen AI pre-2017 because I've condensed all of it into one slide. But we start with programs like ELIZA and Parry and Alice. And these were all essentially script-based programs that simulated conversation. So it felt like Gen AI. And again, this came from that same the same idea that we spoke about with rules-based automation, which was if we can imbue a program or give a program so many rules, a huge list of rules in a script, it can simulate intelligence. So when you spoke to Eliza, it did kind of feel like you were talking to someone, but it was pure pattern matching, really. It was just spotting keywords in your input and then reflecting them back at you. Paul, did you ever speak to Smarter Child on MSN?
No, I didn't know. Not on MSN. No, I'm not.
There was like a primitive chatbot on MSN that you could speak to. I don't know if anyone else remembers that, but I had a lot of fun speaking to that. But again,
I mean, we had a go at writing one of these in a in a previous world. We for Nav we wrote a chatbot that could do some basic things, and yeah, our first stab at this was a massive if statement. If the sentence contains customer, then they're probably talking about a customer. If it says balance, they probably want the balance value. Let's give them that in, and then so we'd say if the sentence contains customer, it goes down this route of a logical route to say, well, they can only really ask for the address or the balance or those sorts of things. They ask for the balance, we take the value of the balance and we return it back in one of 10 various snarky or non-snarky response strings. But it was this huge, we wrote it as this huge if statement. I mean, it wasn't the best way to write it, I've got to be honest. But we ended up having to print it out. We printed out in A3 and put it on the wall, because trying to work out where your thing had gone wrong, it was easy to debug it on the wall because it was so complex. As people, and I think we talk about rules-based automation and how it can be fragile. As soon as someone added a new requirement, or I want it now to be able to tell me how much stock I've got, something, you've got to find exactly where in this mess of if statements you would have to go and put your line of code. So it's possible and it worked. And I think there's also the Turing test piece that people might have heard of here, where there was a whole I think it was $1 million could be won if you could create a computer program that could convince another human that it was a human. And lots of that was about these rules-based engines, but then they would do things like they would pause for a random number of milliseconds before responding, like a human would, and it would say and ah and oh and all these sorts of things to simulate a human. It wasn't being human, but this was this era of, well, if you write enough rules, you can convince a computer's human.
Yeah. And again, it was convincing. At the time, certainly with Eliza, and that was in 1966, the guy who wrote it was supposedly concerned because people assumed a level of intelligence as to him what didn't exist, because it was just a script to him. So when you see people believing word for word in the things ChatGPT says and believing they're human, people were doing that in 1966 with a script. So it's not too crazy. Then we have these neural networks in 2010, and these kind of came from a different question, which was, instead of how do we encode intelligence as rules, researchers asked, how does the human brain actually work? And that gave rise to these things called neural networks, which were just computational systems which mirror how the brain works, or how we think the brain works. So layers and layers of nodes with inputs and outputs and parameters, etc. And we had this boom in hardware with GPUs in the late 1990s, and those got applied to neural networks, which had been a sort of theoretical thing for a long time, but weren't achievable. And in the 2010s, people started building applying it to generative AI. So these recurrent neural networks, which is RNN, and these long short-term memory networks could generate text, but it was sequential. So it would do a sentence and it would do one word at a time, and it would quite easily forget where it was. So long sentences, paragraphs, it would just trip over itself and you'd get a sort of messy sentence that didn't make sense. So the desire was there, the hardware was there. What was missing was the architectural piece to make it work. And in 2017, that got solved. It all changed. Google released a paper. It was really a collaboration between Google and a bunch of universities, I believe, called "Attention is All You Need." And this is where researchers proposed this neural network architecture called the transformer. So that paper is available to read online. Have you ever had a go at reading it, Paul? I had an attempt.
I might get ChatGPT to summarize it for me at some point.
Yeah.
No, not very directly.
Yeah, it's tough. It's a lot of maths, but yeah, seek it out if you want. And then a bunch of people who worked on that paper formed businesses, and one of them co-founded a business called OpenAI. And in 2018, they created a proof of concept called GPT-1, which was applying that transformer architecture to generative language and generative AI. GPT, if you don't know, by the way, stands for generative pre-trained transformer. And now we've been talked about all those things. Hopefully that makes a bit of sense. The pre-trained bit is important, right, Paul?
Yeah, I think this is a thing that took a while for people to get their heads around with generative AI. Is it's pre-trained. That means if we talk about machine learning, we talk about the weather forecasting model or your sales forecasting model. The idea of that is you've got a model that you train with all your history, and then next month or next day you update it and retrain it again. You're constantly feeding back in with the next set of data. Whereas these generative models are pre-trained. They're trained with massive amounts of data. I mean, 170 million parameters, which represents this huge data set. They've gone and scoured the world's knowledge. But the training of that takes such time and effort and cost and resource and, melting polar ice caps that we don't do that over and over again. Your generative AI model from OpenAI or any of the other ones, Copilot, they don't naturally, the model doesn't get updated. It's a brain that comes out of a box knowing what it knows, and then you can give it context. We'll talk about that in a minute. But it doesn't learn. The model itself isn't a learning model. You don't feed back into it. What happens is the reason we hear about the new versions is often what's happened then is OpenAI or whoever else has gone on and trained a new model with a new set of data. They do the training. We don't get really to do that because we don't own massive data centers buried in polar ice caps.
So you get GPT-1, and like Paul said, then GPT-2 with orders of magnitude more parameters, and then we get GPT-3. So instead of the capability of these things sort of flattening as time goes on, it just gets more and more and more powerful, and we start to see all this emergent behavior that we weren't expecting. And it was blowing minds, and it was also making all these earlier versions of GPT completely obsolete. Of note is in 2019, Microsoft began investing in OpenAI. So they put $1 billion in then, but I think over the course of years they put tens and tens of billions in. So they saw something back then, and this was quite a bit before it entered the public consciousness, I suppose. If we move to 2021, 2022, I put the calm before the storm again, because this has all happened before ChatGPT. So 2021, DALL-E, I never know whether to call it DALL-E or DALL-E. This is a very similar thing to GPT, except it's generating images. And then Codex gets released, which is a modified version of GPT-3. And it's worth mentioning because this was a model built specifically to help generate source code for developers and programmers. And GitHub Copilot went into preview in 2021 and then into general availability in 2022. So as early as March 2022, developers and programmers were using these generative AI tools.
It's worth noting that you'll see this pattern throughout all of it, that the developers get the tools first, almost like the people building the tools are helping themselves build the tools. But yeah, you'll always see the first wave of all of these new advancements is coming in the development tools, because those are the people that are hands-on there and they're building their own tools with it.
And we found this wild, didn't we? How when we started talking about these timelines, like how long this had been going on before ChatGPT. I don't think I really truly realized that GitHub Copilot came out before, the standard Copilot that we all know.
Yeah, totally. I think we were talking through these slides a few days ago, and you showed me. I was like, oh, this is after GPT. Yeah, and I was surprised at that point that all this stuff happened. Yeah, before we even started playing with GPT.
Yeah. But then November 2022 hit, and that is when the bulk of us, a lot of us, will have first heard about this new form of generative AI in ChatGPT. So you might have heard the stats already. It got 1 million signups in 5 days, 100 million in 2 months. So it says the fastest growing app in history, but really it's the fastest adoption of technology generally, which is that generative AI technology. And then there's been a steady increase of releases and updates really ever since. But just in 2023, you get Azure releasing their OpenAI service. Then you get the announcement of Copilot across M365, which is where we began to see it in Business Central. March, you get another GPT released. All of these competitors start popping up. They've been around for a long time before that, but going public. Anthropic with Claude, Google with Bard. You get ChatGPT Enterprise, which hints at a desire for enterprise businesses to start leveraging this and with their own concerns around privacy and that sort of thing, which we'll cover a bit later. And then at the bottom, I've just put Copilot and BC ships, and we'll talk about exactly what shipped in 2023 a bit later, but we got drips and drabs of it throughout 2023.
But if you think about that timeline, so ChatGPT really launched in November. 3 months later, there's an Azure OpenAI service. 4 months after ChatGPT hits the main, like is released, Copilot's coming to Microsoft 365. The pace of development here, and I think this is where we didn't, as you kind of we talked about in the previous slide, we didn't see. I think people felt like ChatGPT arrived and everyone rushed to put this new brand new technology they'd never seen before into all their products. And in practice, Microsoft have been doing this for a long time. They've been working with these tools. It's just the public hadn't seen it. They've all been under the water. And I think so it wasn't surprising they moved so quickly and they could move quickly. I think what surprised everyone was it was the business side of that that didn't catch up. It was let's get all these things in. The marketing side, how we go to market with this stuff, how they get presented, how it gets polished into end user tools was the thing that was unknown. The technology itself was pretty well proven. It was how are we going to get people to make use of this stuff? And I think that's what we saw, right? We saw in this period everyone throwing stuff at the wall, hoping something would stick. And how can we take this really cool technology and use it in appropriate ways? And some things were great, and some things weren't. I think there's a lot of, I mean, obviously working in this industry, we spent this year, the 2023, trying a billion different ideas of how we might make use of it, only for next month someone else to have either done that or placed it or realized it's a bad idea or those sorts of things. So it was that year was just a lot of people scrabbling to make use of this technology in some way that make it useful to end users.
And that's still not really slowed down now,
No.
has it? It's
No, I think that's the bit, right? It's the pace of change since November 2022 has just carried on. It's not exponential, but it's definitely linear. It definitely keeps going up, and every week there's a new development in this area.
Yeah. And that did not change as we entered 2024 through to now, which is when we entered what we're calling the agentic era. So this is where AI stopped being a thing that was purely conversational but couldn't necessarily act, and it became something that could act autonomously. So we could give it a task. Key at the idea of agentic AI is this idea of iteration. So it can reason, it has tools with which it can act, but it can then loop around and continue to loop until it feels like the job is done. And we started seeing these in software and ERP everywhere. The autonomous agents, the sales order agent, the payables agent, you've probably all seen. We've got some sessions coming up on those in the coming months if you haven't. But these were effectively people that could read inbound emails, that could extract intent and read files from them, could calculate stock availability, and then raise quotes and sales orders, etc.
Yeah, I think the couple of advancements here in the way because from my perspective, there wasn't a massive change in GPT or transformers or LLMs or these agentic agents to get to this point. It was how we were using them. We went from, if you think about the first time anyone spoke to ChatGPT, you asked it a question and you got a response directly from the model. So from all this training data, it gave its first answer, which was great, but it had problems. What the next step they did, people worked out was, well, and I remember somebody demoing this to me, like they'd hooked it up. They had basically two ChatGPTs, and they'd ask the question to one of them, it would say something, and before they got the answer back, the other model, the other ChatGPT or the other agent would read the other one's response, the question and the response, and edit it and say, oh no, I think you got that wrong. You need to rethink it, and would pass that question back to the first model to reason, say, oh yeah, okay, I'll adapt my answer because you checked that. And they would back and forth, that basically these two models were talking to each other to get to a thing where they both agreed that was a decent answer, and then the user would get the answer. And I think if you now look at if you ever go and talk to Gemini or Claude or Copilot, you see this thinking stage. Often it'll go, I'm thinking, and it takes a little bit of time. And what that's doing is essentially that it's back and forthing between different instances of its own model to say, this is what the user asked me, what should I do? Oh, I think you should go and do, research that piece. Okay, I'll research it. And this is the answer I got. And they talk to each other before they come back to you. So that's how they're editing themselves before they get the answer. And the result of that was a much more sophisticated answer. If you look, even now, if you open up Gemini, I noticed yesterday, there's a question, do you want the answer quickly or do you want it to think? And if you answer quickly, you get a quicker response, but it won't do so much back and forth. So I think that was the big step in making them smarter. They didn't change fundamentally how the models were smart, or they did. It was this idea of using their reasoning against each other. And I think the other thing that, again, I remember someone showing me this when ChatGPT first came out, was the idea of using tools. We talk about agentic. What we mean is it can do stuff in quotes the real world. By real world, we mean emails and stuff. You can argue whether that's the real world or not. But the way we did that was, again, when you give when the request goes to the agent, how do you solve this problem? We say this is the problem, and by the way, these are all the tools you have access to. You have access to sending an email or creating a file or searching the web. And the agents, or the cluster of agents that talk to each other, say, well, they've got these tools, what should I use? And the other one says, maybe you should research that on the web. Okay, well, what should I search for? And it's reasoning on how to use its own tools. So it's really, I think those are the two things that birthed this idea of the agentic era, was thinking, the back and forth thinking, and the idea that the agent, part of that thinking process is the agent saying, of all the tools I have available, their mechanisms to help me, what should I use and when? Before it comes back to the user. It doesn't say, should I search the web for you? It works out that it should do that. I think that's where that's the big step forward I saw. I remember actually going to a Microsoft conference in early 2024, behind closed door one, and they said at that point, they said, obviously we're talking about Copilot today as a chatbot that people can use, but really that's not what we're interested in. What we're interested in is agents. We're interested in the idea that, people give a task to an agent and it goes away for some minutes and does something for them while they're doing something else. That's the big win, and that's what Microsoft saw. And surely that's the same as Anthropic and everyone else saw early on. That was the real win, the real goal.
And they've not let up on that vision, right? Because we've got, as we said, sales order agent, payables agent. We've then got this agent builder where users can build their own agents in the BC client, convert it to code for production if they want. They've then got the announcement of this expenses agent as well, which has been teased for a while, and they've started uploading videos and announcing it officially. I think it was yesterday, wasn't it?
Mm-hmm.
So that idea of an agent-driven ERP isn't going anywhere, or an AI-first ERP. What you're now hearing is agentic ERP, where data serves as the sort of the foundation. Certainly from Business Central, Copilot is that what they call the productivity layer, and then agents all coordinate together, a multi-agent system to plan and reason and then act.
And if you look at how, and if we looking back to this idea that developers get the tools first, that's how a lot of certainly non-BC development, like web development and those sort of things, is happening at the moment. Is it's a cluster of agents doing writing the code with a developer sitting on top managing them essentially. So we are getting there in other areas, and it's only surely a matter of time in theory before we get that in some areas of the ERP.
Yeah, we'll come back to that a bit later actually, about whether there's an agentic era and then there's a multi-agent era, and where are we right now and what's possible. We'll come back to that in a bit. That concludes the timeline. Here is a slide I stole from Microsoft, which you can probably tell because it's got a jazzy animation. This is their view of AI inside Business Central. Copilot and Business Central in the center there. So we mentioned in 2023, they started dropping Copilot functionality in, started with marketing and sales suggestion. We then got the bank account reconciliation stuff. We got the summarizability. We got that ability to chat with Copilot so we can query all of our data with natural language, analysis assist, really nice. Then on the left-hand side are all the agents. So sales and payables, expenses is, I don't actually know if expenses is out or not. The agent builder is also there. And then the extended Copilot family on the right. But that's how it looks now. I suspect that in a year, it will probably have doubled in terms of the stuff they've added.
And just to kind of give a hint for where we're going to talk about in a minute, notice that there's a brackets, Copilot and Business Central included, agents consumption-based pricing. How you charge these things and how you cover the costs is a topic that we need to discuss. It's not straightforward.
And we will do it imminently, because we are now on to the risks and reality section. There are, the risks around AI. Some of the risks that we'll talk about today, people were talking about in the 50s and 60s. It's just now they've become a reality. And we've narrowed it down to sort of 4 broad categories, but there's certainly a lot more than these. And the first one we'll talk about is the one that most people are going to think about, and it's around governance, data security, and privacy as well. So clearly the first one that people are concerned about, the primary one, is that sensitive data leakage, which is these models are, like Paul has said, they're pre-trained, but often we pass data in as context or for it to action, and it's all too easy to accidentally send what would be considered sensitive financial or customer data to, I put there an unsanctioned tool, or just simple user error. You've got some sort of sensitive information in a document and you accidentally send that. Normally unintentional, but it is serious.
Yeah, and you've got to think it's so even if we consider the model, if we never retrain the models, or if Google or Microsoft or OpenAI never retrain the models, so then we never had this concern of all our data then surfacing back as answers to other people. These models are still hidden behind other companies' infrastructure. You are still opening up a Microsoft window or a Google app or anything else, or any other third party. You're still sending that data to them to pass to the model. So it's forgetting whether it's AI or not. It's still, would you send that piece of data to that other business's systems, their IT systems, to be able to catalog? And do you know what they're doing? That's the fundamental question.
Yeah.
Not to mention the idea that what if they retrain on your, contract data?
Yeah.
Yeah.
It's probably worth mentioning that there are tools on the LLM side and on the AI side where they will try to, if they catch that you sent some sort of sensitive information, they will try to let you know, but not always going to catch it. Is the key bit there.
But those aren't part of, and again, those aren't part of the model. And I think that you take like ChatGPT is based on a model, an LLM, an AI from OpenAI. But but other people can integrate directly to that. Bypassing ChatGPT, you can write code that sends your data to an OpenAI model, to to the AI through your own infrastructure. So it's really about who are you trusting your data before it gets the AI, as much as what is the AI. It doesn't matter if it's OpenAI in the background or if it's Claude. If you're sending it via some third-party app that says, I've got an AI button, you're sending it to them first. And I think that's the big, I see that as the big risk here, that we should consider.
Yeah, and that's third-party extensions, that's tools, that's MCP servers. Yeah, you've got to know what you're using and where it's going. Somewhat related there is this idea of data residency. So where does that data go when AI processes it? It's a GDPR thing, really. So Copilot keeps EU data in the EU data boundary, and that's because if it were to go to a different area, there are different GDPR rules around it. And again, the key there is that BC Copilot or Copilot adheres to the EU data boundary, but tools you're using might not. So just something to be aware of.
And like from our perspective, running a business using this stuff, our general MO, modus operandi, is we trust the Microsoft platform. We would be in the wrong business if we didn't, but therefore we use Copilot because we know where the data is going, as opposed to third parties. So it's a big benefit of being in the Microsoft ecosystem that, the same way I trust my emails are staying in the boundaries and my Teams chats and my SharePoint documents, we have the same controls and visibility and trust within the Microsoft ecosystem for Copilot.
And then the third sort of a risk and sort of reality as well is this idea of shadow AI, which is staff using AI tools that fall outside perhaps the quote unquote sanctioned ones by the business. So if they're using a personal ChatGPT instance, or they're using a tool that the company hasn't signed off, all of that stuff around GDPR and governance just falls apart. It bypasses all of it, exposes data by accident. There are obviously spend implications because you might end up double up on spending. So another reality to consider.
Yeah, it's that thing. I think some people did this when these tools first became available, and quite a lot of people, 100 million users worked out they were useful. IT departments were slower maybe to get the rules out, so they published nothing. They didn't set any restrictions. They said don't use it. Well, people are going to use it. They're just going to use their personal accounts because it's so easy now. So I think my guidance to most people when they ask me is set a policy. Even if you think it's not perfect, set a policy that allows one way for people to use these tools. Because if you give them no route, water finds a way, or they'll just go and open up ChatGPT or Gemini and do it themselves, and that's worse. So it's all about, you've got to get a policy out there. I think if you take nothing away from this session, set a policy. Set a policy in your business. You haven't already got one about how to use these things. Even if you don't think it's perfect, it's better than not having anything.
Yeah, because you read online about specific industries. Law, legal is a classic one where they're a bit slower around adoption because there's so much sensitivity around data, and people just spin out their own instances of ChatGPT and use that instead. So
yeah,
bit scary. Number 2.
We do have a few questions in the chat before we move on. The first one is redacting sensitive information a protocol we can use.
Oh, sorry, I'm gonna. Is redacting sensitive information a protocol we can use? I don't know. I don't know a standard tool that does that. I think it's a good idea in terms, but you have to trust the user to do it. I must say, I don't know an AI tool that redacts sensitive information on the way in. I think the problem is if you want the AI to work out what data to redact, it's got to look at the data first. So it's a difficult one to implement.
Yeah.
I think we'll talk. I don't know if we'll talk about this session, but we are seeing more and more tools where the AI lives locally on your machine for certain parts of it. So for those sorts of purposes, so I can definitely see people going to do it where, you ask a question into your AI, the first thing that happens is locally on your computer, it uses a smaller model or a simpler AI to redact things and then send the redacted stuff up. I think it probably is where we're going to go with some of these things. But yeah.
The other one is, does the EU data boundary apply to the UK still?
Yes, as far as I'm aware. Certainly we act as it does. So yes.
Yeah.
I don't know. That feels like a leading question. Like it doesn't. Yeah, I'm going to go and check it now. I'm going to go ask ChatGPT. But yeah, as far as we're concerned, yes, it does still apply. There's still GDPR and those sort of things still apply.
And finally, can we deploy an NLP chip and run AI agents locally?
Yes. This is my current fascination, to be honest, is running agents locally. It's a deeper topic, and we'll talk about it probably when we talk about costs. But yes, you can run AI agents locally, but unless you've got a really powerful machine with a bunch of RAM, like a few hundred gigs of RAM or 128 gig of RAM, and a really strong NLP chip or GPU, whatever you want to call them, or whatever sort of chip you can run it on, it's not going to work as efficiently and as quickly and get as good a results that you'll get out of Copilot and Claude and ChatGPT, because those things are just running on really powerful hardware. But I think we'll see this balance of running simpler things locally for simple tasks and then going to the cloud when it's a more complex task. So you can run them locally. If you want to go and download, there's a product called Alarma that will do it. This isn't me sanctioning it, it just exists. But that's a really quick and easy way to run local model agents on your laptop. And then you can heat your room because the laptop will get warm and you can save on your electricity bills that way. But yeah, it does work. And we're seeing more and more of it. I mean, Google just released models that are run on a smartphone and are pretty smart.
And there's a question there, isn't there? We talk about this forever. There's a question there around a lot of people want to default to using the biggest models they can. But actually, if you can run a maybe less computationally intense model that does the level of reasoning you need, then there's really no need to use something huge like Claude Opus 4.7 or something. If you can host something local and do 80% of your work using that smaller model and then outsource to stronger models.
Yeah, it's the Apple model, right? This is the Apple intelligence idea. Apple made the move that they're going to try and run all their AI locally on your device. So when it does that thing of like scrubbing out people from the background of photos, it's running locally on your device using a generative AI model. Yeah, I think we'll see a lot of work in that in the next couple of years.
Risks reality 2, hallucination data quality. Again, one that probably a lot of people are aware of. When we talk about hallucinations, we're talking about an AI responding to us or generating content that is confidently fabricated or inaccurate. And I will admit that this has gotten much better since, if you consider how often AI is hallucinated in 2022 and now how often they hallucinate, it has gotten much better. And we can also control a lot more of that by using context and data quality, which we'll look at in a minute. I suppose the idea here is just do not blindly trust everything that an AI says to you.
Yeah, I mean, I was saying you probably before. I was reading a book recently, well, listening to a book in the car, and I kind of zoned out and got to the end of the chapter and thought, I don't really know what happened there. And when I got home, I think I went to Gemini and said, what happens in chapter X of this book? And it gave me this like the summary that was totally fabricated, such that the characters were barely recognizable. And I sort of said, that's not right. They went, oh yeah, you got me. Yeah, yeah, my bad. Oh, this is actually what happened. And it gave me another response, which was totally made up, like absolutely fabricated. And then third time I said, no, go and look on the internet and find it and then tell me. And it came back then with the accurate answer what happened. But it took a couple of pushes, and that was on, that was this weekend. So it's not a problem that's gone away. I do think people have got better at spotting it. We like much how when Google first arrived, people didn't know how to use it to search the internet, and we got better at searching. I think we are, as a people, getting better now, understanding this and identifying it and checking it. It's worth noting that I noticed in Gemini when I had that problem, Google's added a button called "Check This," so you can get a response from an AI and then it press check this and it goes and Googles what the AI said and validates it. So we are seeing tools and it's this framework around the models getting better at it. I don't know if the models are getting particularly better at it. We're just putting more controls in place around it to control them. But yeah,
and around and around spotting those areas, you mentioned earlier on that you're seeing much more of the reasoning now, so you can follow that train of thought. So when you see the spark of an idea that seems wrong, you can then maybe say, oh, well, when it said this, that probably isn't true because it made this assumption that isn't correct, etc. Data quality, another big one. Oh, sorry, before we get to data quality, cascading errors. So this is just a reality, which was, we talk about hallucinations that are obviously bad, but now we have agents that will have this loop where they will reason and then they will act on it, but then they will loop around and around and around. So clearly one hallucination is bad, but an agent that hallucinates right at the beginning and then does a bunch of stuff over the course of 10, 15 minutes based on that hallucination, even worse.
Especially one that's connected to your email account and is sending emails. Yeah.
Oh yeah, yeah. You would expect that the news would die down of people using agents to delete entire databases and all their emails, but I saw one, I think 1 or 2 days ago. It's still happening, so be careful. Finally, data quality. This is more of a reality. You always hear data and AI. People harp on about it's only, the AI and the reports and analytics, that kind of stuff. It's only as good as the data that you work with. So when we're passing good data in and accurate data, you'll get good responses. And if we're not using good or accurate data, we can expect not to get particularly good responses.
Yes, they don't
just
know
consideration.
Yes, you are. Yeah, that's exactly the thing. They're kind of like children. It's more like an alien intelligence that we're using. You have to give it the context. You have to tell it the stuff, and it will trust what you tell it to be true, which is always worth considering.
Yeah. Number 3, a reality. So we just touched on this, but it's the escalating cost. This has been I suppose threatened is the wrong word. We've seen this coming for a little while now. To illustrate how quickly this moves, this was the original bit I was planning to use to illustrate the escalating cost, which was recently Claude Opus, a new model, was announced by Anthropic. And the multiplier, which is effectively how much it's going to cost us to use it essentially, was considerably higher in GitHub Copilot than most other models, which is essentially a flat price increase. But even since then,
so just hang on. So just to explain a few of those terms. So
yeah.
So yeah, GitHub Copilot is a coding agent that we use to write code. And the way that works is when you ask it a question, it uses a thing called premium request. So if you asked a model prior to this a question, it got the answer and it did your code, that would cost you 1 of these credits. And this model they released was every one of those was going to be 7.5 times more expensive to you. So every question you asked was going to be 7.5 credits. It was going to cost you 7.5 times the cost, not of ChatGPT from 3 years ago, but from the model a week or 2 ago. That was a massive jump.
Which again leads us back into that. Okay, there's more decisions to be made around, do we need to use the biggest models now, or can we get away with these smaller models? But even so, that was that last week, or I think it was last week that happened. But even since then, there's been more changes to how GitHub Copilot usage rates and limits work and costing. So that threat of escalating costs, specifically in tools like GitHub Copilot, has become a reality now. It's all getting a bit more expensive. In terms of what that means for Business Central, Paul mentioned it earlier on when we looked at that Microsoft Copilot slide. There's a few different ways of of paying for Copilot and AI inside BC, Copilot is actually included. So stuff like those product description generation and bank reconciliation assistance, etc., that's all included, which is lovely. But Microsoft have signaled fair use policies, and clearly if people really abuse these pieces of functionality, they might end up introducing quotas. And agents then have a separate licensing model. So they use these things called Copilot credits. And the more work and actions and tools that your agents use, the more Copilot credits they will use. So by all means, have a play around with Copilot and with agents, but do remember that agents are consumption based in terms of billing.
And this is, we expect this. I think we've known for quite a long time that private equity has been funding AI, or yeah, there's been massive amounts of private equity pushed into companies like OpenAI. It's worth billions and knocking trillion almost because of this. It's not making money, it's consuming cost buying data centers, building like these huge sets of hardware. And at some point we've got to start paying for that. I think what we don't know is now whether there's really two passes. Either these big companies are going to keep fighting to have the best model and keep investing their R&D, in which case costs are going to go up, or are we going to accept that no, the kind of the problem is almost solved, now we need to drive costs down by not investing so much in R&D but in optimization and using the hardware we've got. So I think we'll see this. There'll be an interesting divergence. I predict that some will continue to become the latest and greatest models, and other companies will settle and say, Claude Opus 4.7 is good. It's really good. We don't need to keep rapidly improving that. What we need to do is bring it down to a cost that makes it more efficient. But certainly, I think we'll see more focus based on these changes over the last month or so. We'll see more changes into things like about people having systems that will optimize your AI usage. So instead of saying you decide you want to use that expensive model, you ask some other AI that works out correctly the most efficient model for the question you're asking. And I think we'll start seeing businesses set up massive industries saying we'll cut your AI costs in half. That'll be their technology model. So I think we will see a lot of that. Not to mention running things locally on your machines will become potentially a thing that becomes more viable now. So yeah, there's this cost element is going to really affect how we build and how we use these systems going forwards.
Exactly. So given that, I suppose some advice from us would be that free or cheap AI does not mean it's going to be free or cheap tomorrow. And again, we are seeing that in real time now. So if there are processes that you want to integrate AI into, start thinking about what the cost to run those is now, and start budgeting for integrating AI with it now as well, ready for those potential increases. And we've got a final risk and reality, which is the bigger picture. And this is the more existential stuff. It's things like skills atrophy. What happens when we outsource all of our work to AI? What does that mean for how we learn new skills? What does it mean for our existing skills? The one we were talking about the other day is people always talk about using Outlook is using AI to draft emails and things like that. But is that a skill that you want to atrophy, the ability to write concise emails and communicate?
I think that's a broader question. I think as we discussed, that one in particular is interesting because I wonder, do we assume today that the thing reading our emails is a human and therefore we write for a human audience? How many people these days are just reading the Copilot summaries in Outlook and not actually reading your email? And as such, are we going to have to start writing emails with the context so that the AI on the other side is getting enough context to accurately summarize it to the human reading it? Are we going to end up with, human writes one sentence, AI generates 5,000 pages, AI reads 5,000 pages and condenses it back into one sentence? So we're going to end up down that route. But I think you're right. But in terms of the skills, actually, I think you're right. I think it's how are like the next generation going to come through in business or in work? How are they going to learn the skills that we're currently passing off to an AI? How are we going to train them in doing those things? Be it writing code or or researching or deep thought, all these sorts of things. How are we going to train them if we aren't doing it anymore?
Yeah. And the answer right now is who knows? It's all up in the air, isn't it?
Yep.
Another one, workforce displacement. And you hear this a lot as well. These agents are often explicitly positioned to allow business growth without having to recruit more people, which, you know, financially sounds good, but in terms of the effect on the workforce, that is not good, especially when we've already got, you know, issues around unemployment, more workforce displacement, not good.
Yeah, it's a hard thing. It's exactly that. It's interesting because this isn't even a generative AI problem. I'm pretty sure it was a problem in the 60s when we started using computers at scale in business. It's always been that thing of, as we automate, what do you like? Are we putting people out of work? And if so, what are those humans going to be doing? Yeah, the argument is we should find more useful, more human related things to do. I think one of the things that we've seen is, and I tend to talk to people about, is the last thing I think you should do is put AI in front of your customers. Of all the things I think still needs human, you could argue still needs a human interaction point, is talking in that relationship with customers. If you've got that sort of customer base, immediately taking that as your first step to replace the AI seems risky and seems like the one thing that you want to hold precious and dear and human. So I think we'll see some of that impact in how we implement AI in the future.
Yeah. And then on a similar note, it's this risk of widening inequality, and that kind of links into what we're talking about around potential price increases. The businesses and the users as well, developers and consultants that can afford this AI and can afford to adopt it, are going to keep up, and the ones that don't are going to fall behind.
Yeah, especially if we're seeing having access to better AI models or AI in general as being a 2, 3, 4 times multiplier on efficiency. The person that can't access it is all of a sudden really going to be struggling to keep up. And how do we? I have no answer to this problem, but it's definitely.
Yes, something to consider. We have a minute to go, so we might rattle through this slide a little bit more quickly, or this section. And this is where it's headed: the roadmap, big picture, and what you should do next. In terms of the near-term BC roadmap, we kind of covered this earlier on, which is Microsoft proposing this agentic system where we have lots of different agents doing specific roles and orchestrating and working together. Mentions their expansion into finance workflows. Again, we've got expense agent and things like that as well. And we've already spoken about this notion or this concept of agentic ERP. And there are some stats here around supposed increases in productivity related to things like GitHub Copilot and then M365 Copilot.
Yeah, I think we'll definitely see more and more agents from Microsoft and from third parties. You know, all this partner ecosystem. We will be building, companies like us and other partners will be building agents that pick up and do parts of the roles that people currently use BC for. So we do see that is Microsoft's their direction of travel is they want to see more and more agents using BC, and they're encouraging partners and themselves to build those things.
Yes, exactly. And this ties into it when we look at that progression where we've started. We started really with not AI, again, with stuff like rules-based automation. We moved to machine learning for predictions. We then get this conversational element with Copilot that also is generative. Finally, we then move to agents where these things are acting autonomously. And then we have this idea of the multi-agent system, end-to-end orchestration. So I suppose we're technically in the multi-agent era, but we haven't seen multi-agent adoption, maybe is how I'd put it. What do you think, Paul?
Yeah, I agree. I think in certain industries we're definitely in development and those sorts of more technical industries, we're seeing multi-agent where one developer is overseeing 3 different agents doing work and then kind of managing them. I think you look at what Microsoft have done with the new agent control panel. There's a reason it looks like that, and you've got the agents across the top. It's they see that you as a human are managing that set of agents and only reacting when and the agent comes to the user when it needs a bit of help, but mostly it just is silently getting on with it. So I think Microsoft, you can see that is the direction of travel. We can see that they're building user experiences for it. Now we just need more agents in production to make those things work.
Yes, exactly that. And like Paul said, the human role in that way has shifted from doing to reviewing and approving 1, 5, 10 agents at the same time. Finally, what to do next? So we've got 4 little tips here. The first one is pretty easy, and it's to use what you've already paid for. So we spoke earlier on about all of those Copilot bits of functionality that are included in your Business Central license, bank recs, marketing text generation. Have a play around with it. It's all included, so you may as well. Try agents and agent playground. The next few sessions we've got are going to be on agents. I think the next session is exploring standard Copilot functionality, but then we're doing sessions on agents and agent playground. Again, bear in mind that there is a separate model in terms of payment for that. It's a consumption-based model, but have a play around with them. I stole this from someone at Days of Knowledge, and I'm shamelessly admitting it, and that's to pilot a low-risk process. So if you're looking for a way to integrate AI that isn't necessarily Copilot, maybe all these agents, find a business process, one that's well-defined ideally, and think about how you could integrate AI to improve it a little bit. Either to take the burden of work off of someone or to make it a bit faster or a bit more accurate even. And the last one, maybe the most important one actually, is what Paul discussed earlier on, which is to set your governance position. So decide your stance on AI use, GDPR, the tools you want to allow, the tools you don't want to allow, before you roll it out. And that is almost the end. I have one final ask, and that is, could you please, pretty please, complete this questionnaire? It's a relatively short Microsoft questionnaire. We will make it worth your while. You will be entered into a survey, into a draw, I should say, where you will receive a £50 Amazon voucher, or if you're feeling generous, a donation to a charity of your choice. With that, I believe we are all done. Do we have any questions in the Q&A section that we have not managed to get to yet?
No, you've answered everything.
Nice. Well, our emails are all up there. So if you have any more questions that you haven't asked in the Q&A bit that you want to ask, or you have bigger, grander ideas that you want to bounce off of any of us, please grab our emails and send away.
Well, if you just want to spend an hour talking about AI, because we'll do that as well.
Oh, yeah. Oh, yeah.
Yeah. If you want to do your ear bent about AI for an hour, yeah, we can do that. Cool.
Thank you all for coming.
Yeah, thank you very much.
Yeah, and we will see you hopefully in the second session of our AI webinar series.
Thank you. Thanks all. Have a good
Cheers
day.
all.